sketch, with your help, I'd like to sketch this. For a reason. 1/2 raised to the x. Okay, so Professor, I saw you use a table. May I use a table and plot some points from a table and see what 1/2 raised to the x looks like? You could. In fact, I'm going to suggest to do that first. Guys, so if I do a table, and there's nothing wrong with the table, and a selection of numbers, let's throw a few negative numbers in, 0, a few positive numbers in. And then for this one, it's 1/2 raised to a -2. I'll come back to it. 1/2 raised to a -1, I'll come back to it. 1/2 raised to the 0, come back to it. 1/2 raised to the first, come back to it. And the last one, 1/2 squared. And then I'll plot points. Now, can anyone tell me what is 1/2 raised to a -2?
4.
4. Okay, so I'll go to the 4 there. And then try to plot these points. Okay, start with the 4. Next, I see 1/2 raised to a -1, maybe 2. 1/2 raised to 0, anything raised to 0 power, guys, is 1. Is it true? Mr. Park, with your higher math, I said anything raised to a 0 should be 1. Looks like 1/2 raised to the 0 should be 1. Pi raised to the 0 should be 1. Square root 2 raised to the 0 should be 1. How about 0 raised to the 0?
Undefined, I don't know. I'm not sure.
That's what you're going to see in one of these upper division calc courses. What's 0 raised to the 0? Can I call that 1? I don't think so. We don't have to worry about it here. This is 1/2, of course. This is 1/4. So you say, Professor, what are you going to do? I'm doing this. I have an ordered pair to work with, ordered pair with the help of a table, ordered pair, and an ordered pair. If I've been copied down correctly. I need to just plot, connect, and see what this graph looks like. Some students may realize what the graph looks like now before I even plot it. But based on my points here, let's see what it does look like. Okay, guys, we're going from a -2 to a positive. This. Get ready for it. -2 up 4. Okay, -2 up 4. Are all these points correct here so far? So -2 up 4. A quick sketch. What's up here? -1 from the table looks like it says go up to 2. I'll plot it here. 0 goes up to 1. I'll plot it here. 1 goes up to 1/2. I'll plot it here. 2 goes up, barely up, 1/4. And I can plot more points. Is that enough to see the shape of the graph coming out? If I connect the way it looks right now, please tell me, does it look something like this? As a graph. Now, Ignacio, I did my table. Can you remind the class what, as we set a break, what did my graph of 2 raised to the x, not 1/2 raised to the x, 2 raised to the x that I did down there, what did that graph look like?
That graph reflected over the y-axis.
Okay, you say this. I think this is the graph I was doing right before the break. Is that true?
Yes.
And the black graph is the one I just did with the help of the table, which is this. What's the relationship? Nothing, not you said it. What's the relationship between the blue, I'm calling that the parent graph, between the blue graph and this black graph, any relationship going on? And you described it as?
Reflected over the y-axis.
He says, Professor, if you take that blue graph from before the break and flip it, reflect it across the y-axis, this piece becomes over here. This piece comes over here. Is that true? So is that graph reflected through the y-axis? Now, I did it through a table, just to point out. Billy, the black graph. Now let's get the blue one out of the way first. Tell the class real quickly what the domain is. We'll use the blue. What the domain and the range is on the blue graph. What's the domain on the blue one? Just based on the graph. From x, this direction, on the x. It is. And how about the range, the up and down, the y values on the blue graph? 0 to infinity. Now, on the side here, I like to have the domain and the range on the black graph. Guys, look at the black graph, tell me the extent of the x's here for the domain on the black graph.
The same, negative infinity.
Is it negative infinity through positive infinity? Is it the same thing? How about the range on the black graph?
The same.
Is the same. Did they interchange? As you've seen me do some tonight, did they interchange? So I'm not talking about inverses here. Is that true, guys? So those two functions are not inverses. They're graphs, yes, they're functions, but they're not inverses of one another because the domain and the range did not switch on me here. But something's going on. And Ignacio, we do this with the class. Could I did it with the table. Could I have been wise and say, wait, Professor, could you not express the original function to begin with like this? Is 1/2 raised to the x the same as 2 raised to negative x? Do you think 1/2 raised to the x is equivalent to that? Yes or no? If it is, through transformations, notice that negative sign is up there, it's not out front. If the negative sign were out front, I'll tell you ahead of time, it would be a what? A reflection through the x-axis. Since the negative sign's up there, since we've had transformations, what type of a transformation would you have to do on this one if you want to use transformations and not a table? What does that negative sign indicate up here if I want to do it through a transformation? Reflect through, what was it, the y-axis? So if I had known that ahead of time, some of us just probably do it. I said, Professor, just take that blue graph and reflect it across the y-axis, and you'll get the graph you're seeking. And not have to go through that table. Is that true? You're done. Finished. Now, as I said, though, part B, let me sort of close this down. I'd like to sketch this. I brought another one in here that I thought I wanted to look at with you guys. Hang on. Oh yeah, this one's nice. We'll call it h of x. And it looks like this. Bear with me. I'll try to use different colors, as much as I can. Nice. I'd like to graph that. And not this time, not use a table. Use transformations. Now, can anyone tell me the negative sign stuck out front may tell me to do what? That we've seen so many times. It says reflect through the x-axis. I'll use that in red when I get to it. Let's hope this blue marker will work for me. Now I see, yeah, it will. this is another what? Reflect through y-axis. And let's put that +4 in black. Finally, this means what? A vertical shift up 4. We've done these transformations. And I need a parent graph to do those transformations on. True? And what that is, that's my graph that I'm looking for. Guys, this one, let's see what's going to happen here. The parent graph. Well, the parent graph is going to be 2 raised to the x. The one I saw earlier. Let me put that in a color here. Let's try green, see if it'll work. 2 raised to the x. We saw it before. Did it take a shape something like, no, not this one. Did it take a shape like, let's see if this will work. This. Yes or no?
Yes.
We'll label this. This is my parent. Right. We'll do these 3 transformations. Now, the red says reflect that graph through the x-axis. Don't let me make a mistake. Tell me, guys, is that point right there on the green graph, is that 1, the y-intercept?
Yes.
No, put that just for sake, you know it's 1. Reflect through the x-axis, this green graph. Please tell me, is it going to look something like this? Before I put it in.
Yes.
And let's label this as y is equal to negative sign out front, 2 raised to the x. That point there should be 0, -1. Thank you. Now it says don't stop there. Now do the blue. Blue says now reflect that red graph through the y-axis. Please, guys, tell me, do not make a mistake. Might it look like this? Reflected, the red reflected through the y-axis. Labeled as, at this point, I have this, and that. You guys agree? Last thing is, here goes the most important part here. To finish it up, I guess I'll finish up in black. Vertically shift up 4. Let me go ahead and mark my 4 here. Get ready for it. Now, can anyone tell me as you start vertically shifting that blue graph up 4? Can anyone tell me something I should be aware of? Because this is going to be the final, this is the answer. What should I be aware of as I try to shift up, vertically shift up the blue graph? Okay, thank you. It's -1 down here. Definitely add 4 to it. That point's going to land at what? 3? So I will have this point for sure on my final graph. That's beautiful. -1 here, shift up 4, add 4 to it, 3. Okay, what's everything else I should be aware of? Oh, tell me again. Shane. Shane says, Professor, you better be careful. There's a horizontal asymptote being involved here. Where is it? It's the x-axis. You had better, as you shift up 4, you had better shift that x-axis up 4. It's also being shifted. So up here, I'm going to place it with Shane's help there. Up here. And let me make it look like a hole for me. Make it look like this. And I'll get out of your way here. And label this as y is equal to 4. That's true? I don't have the final graph yet. I have a horizontal asymptote up at 4. Now what? my graph? Should it resemble the blue graph? It should be doing this. I have the same type of a curve as the blue graph. So if I did this right now at this point, this is a rough sketch, I would say it looks something like that. Head toward the horizontal asymptote. Yes or no? And the further I go out, the closer it gets. So I'm gonna say this represents y is equal to negative 2 raised to a negative x plus 4. Would you guys agree with it? The final graph. Y-intercept is 3. Now, I usually ask you also to find what? What's the x-intercept? I heard negative 2. And usually on the side here, on these transformations, I do ask for both. So let's go ahead and find the x-intercept here on the side. Guys, go ahead and find x-intercept. Algebraically, it's to set the function equal to 0, which would give you this to look at and solve for x. Move the 4 over. No problem. Divide or multiply by negative. Makes it much better. Now, can anyone tell me at this point, what should I do to finish it up? Don't say divide by 2. It's not divide by 2. I know that'll give you 2. But that's not what I want here. So can anyone tell me what should I do at this point to solve for x? Yes?
You can present 4 as 2 in the second.
Beautiful. Rewrite 4 as 2 squared. And the other side has a 2 already. And they have the same base. Therefore, using a little logic here, these two must be equal. So 2 is equal to a negative x. X is equal to a negative 2. I think I heard a student tell me earlier, Professor, that's my x-intercept, negative 2, 0. So I got the x-intercept, y-intercept, horizontal asymptote, and that's my graph. Are we okay? That's how that looks. Let me step back and look at it. Looks cute to me. Got any concerns here? Any questions? Hang on. Domain. The domain of the black graph, which is the final graph. What's the domain, guys, on the black graph as you go from left to right? All reals. No problem. Now be careful. What's my range up and down on the black graph? And it's headed toward what? 4? Will it ever get to 4?
No.
No. So they can be up to 4, getting to 4, close to 4. They'll never get there. So that's where my horizontal asymptote is located. Isn't that nice? Done. Now, with that said, that's part 1. Part 2. Now I gotta slow down, let you guys practice with something I brought in tonight. In fact, you know me, if I can find it by the time I get to it, it's one of those problems where I throw it out and I say, if you can work it out, you can get the answer, you will be exempt from the quiz on Wednesday. You get to leave the class a little early, and you get your 10 points. It's one of those. If I have time tonight, let's see if I have time. Guys, with that said, hang on. Mr. Park, I'm checking to see if I'm close to where I need that handout. Hang on. Here goes. Okay, part 2. Find the domain. No sketch needed. First one. F of x is equal to this. No sketch. Just tell me what the domain is. What's allowed for the x's. Can someone in this clever class tell me? I'm not going to sketch this. If you were to sketch this, there's one transformation needed. First, use your parent graph, 2 raised to the x. Can anyone tell me, based on what you see up here, what is my one transformation that's needed here? Alex.
Graph, move
a horizontal shift to the right 3. The last one I think had a vertical shift up before. This one he says, Professor, take the parent graph and horizontally shift it 3 to the right, and you'll have the graph you're after here. Without the graph though, can someone tell me, you may want to visualize the graph, what do you think its domain is? What can I replace x by? All real numbers. It can be anything. Right, like this. Done. Part B. Have another one here listed. Think. G of x is equal to log base 2 of this. I want its domain. No sketch needed, unless you want to. Now, can anyone tell me, what would you do? Anyone remind me before the break, what was the domain on a parent log graph? Not an exponential, this was an exponential up here. What's the domain on the parent log graph? 0 through infinity. So what does that tell me to do here to find the domain on this one? It's right here, 2x plus 5. Makes sense? Must be what? Gotta be. Let's align with the parent graph. Solve for x. There's my domain. Integral notation might look a little better. Yes or no? Okay, letter C. There we go. Next one I brought in looks like this. H of x is equal to log, and in this case I have 16 subtract x squared. I'm going to look at this. This marker will work for me here. Now, one of my students came up to me at the break. Says, Professor, in talking about logs, I know you have a subscript 2 here. Could it be a subscript 3? It could be. A base 3. Subscript 4? Yes, it could be. And there's one that's so common sometimes in mathematics, they don't place it. But it's understood to be something. And he was asking about that. Does anyone recall what, if the base is missing, it's not written for you, what is that subscript, that base meant to be? A 10. It's a base 10. It's called a common logarithm. So if the base is not there, and sometimes they do not have it there, it's understood to be a base 10. But no matter what, it's a log. Domain, I think my students are saying, Professor, it looks like it's another one of these where you got to do this. True? Then I could factor this one. I know some students would like for me to move from one side to the other side and do something, but I'm going to factor. And what do you think I'll use now that we've used so much in this class to finish it up? How can I solve that inequality? Sign analysis. And my critical numbers here to solve this on the side, all this math is coming together now. Critical numbers are what? -4 and 4. Cannot use them. That's true, guys? And then you start testing, and since we've done sign analysis so much, does anyone think they know when I test here, test here, test here, which interval is working? Now go ahead and shade. Or should I test? Remember how to do sign analysis? We did so much of it. Does anyone have an idea of which of those 3 intervals, if I should do the test? Does this work? That work? This work? All of it works except those 2 open? Shane, what do you think?
So my brain just short circuited, sorry.
Anyone? Alex? In between, hang on. We have forgotten sign analysis. I'm going to test. I'm going to choose -6. I'm going to test. I'm gonna try 0. I'm gonna test. I'm gonna try 8. We've done this before. Now, try -6. Here I go, guys. I'm replacing x by a -6 right there. 4 subtract a -6. That's a positive 10. 4 plus a -6 is that a -2. That product is negative. What are we wishing for? A positive. Aren't we? Greater than 0? Is that true, guys? In between, we'll try 0. So 0 there, 4 subtract 0, 4, it's a positive. 4 plus 0, positive. Gives me a positive. Alex, I think you're the one who told me, Professor, I think it's the in between. And I did my sign analysis. Guys, is it working out to be that? And out to the right, 8. 4 subtract 8, that's a -4. A little review here. 4 plus 8, that's a positive 12. Another negative. So the only positive was in between. So my domain here is -4 up to 4, not included. True? Absolutely. No problem there. My last one, and then we'll move into something else and close down. But I want you guys to practice with something here. Letter D, last one here. Find the domain. I need your help on this one. Let's call this f of x is equal to log, let's call this base 3 x squared. It's for a base 3 this time. Now the question is, what may I replace x by? And find the domain. That's my last one for domain. What is allowed for replacement for x? Again,
All real numbers.
Shane. Here we go. She said, Professor, you may replace x by anything. I disagree. There's one you cannot use. One number.
0.
I cannot use 0. Because if you take what? Square 0, you get a 0. Is there a log of 0? No, what was the domain on that parent graph? Was it 0 through infinity, not including 0? So I can use 0. There's no log of 0. So here, not this, my domain's going to be, if I want to put it in interval notation, -infinity up to what? 0, union 0 through infinity. For my domain. That's true, guys? Okay, so just be careful with that. Now, the way we're going to close down, almost, not quite. Students, I'll let you guys look at this little extra credit problem here. Hang on. Okay, here we go. The same student at the break who came up to me was talking to me, says, Professor, if that's missing, and you might think on a quiz or an exam that I was not careful, and I forgot to put the base in there, this missing is understood to be base 10. So before I jump into this, look at this. So this says, if you want to find the log of 100, and it's understood to be base 10, what's the answer? 2. Now you gotta tell me, why is it 2? Does it mean this? Is that what it means? If I ask you, before we go any further, log base 3 of 27. Answer is 3. Reason? Because this means base 3 cubed is 27. Another one. Log base 2 of this. I heard it's -4. Now, why? The rationale, 2 raised to a -4 is the same as 1/16. So we're actually saying the same thing here. One more. Log base 32 of 8. Why not?
3/5.
Oh, I'm hearing an answer already. Hang on. Log base 32 of 8. Does that mean to divide 32 by 8 and get an answer of 4? I wish. That does not mean 8 into 32 4 times and say the answer is 4. Not quite. Anyone have one of my students, I think, has the answer, but I'm gonna hold off. Anyone else? This one's tougher. Now, what can I do? And you do? So, wait, Professor, this one's tougher, but I know it means this. 32 is being raised to something to give me 8. That's an exponential. That's what it means. Now, a clever way to find x at this point, why not rewrite these two in terms of the same base? We'll use base 2. What does 32 look like written with a base 2? 2 raised to the 5th, x. And what does 8 look like with a base 2? 2 cubed. Do I now have the same base on each side? Therefore, my goodness, this, it's got to be equal to this. You got 5x is equal to 3. X is equal to 3/5. There's your answer. Yes or no? One more. Over here. Log base radical 2. Oh, by the way, can I use radical 2 for a base? Yeah, anything but 0. Can't use a 0. It's got to be greater than 0. Can't use 0. Log radical 2 of, here goes, 64. Like I said, Professor, I don't quite see it right now, but, help me out. Here we go.
We can present square root of 2 as
2 raised to 1/2?
Yeah.
That means what? 2 raised to the 1/2, that's square root 2, right? Being raised to something, it's supposed to give me a 64. Is that what that means? And I'm looking for that something, that x. Guys, I'm running out of space here. It merely means 2 raised to the 1/2 x is equal to 64. Is it possible to rewrite each side in terms of a common base? Yeah, 64. 64 could be expressed as 2 to the 6. Right here. Therefore, now I can actually say this must be equal to that. So I got 1/2 x is equal to what, 6? My goodness, guys, is the answer 12? Good job. Done. Last one. Log base pi. There goes. Oh, can I use pi as a base? base pi of radical 5. Is it doable? It's doable. But, Mr. Professor, I know what it means. It means take pi, raise it to something, and you get this. You guys agree? Is that what it means? Good luck. Where pi is roughly what, 3.14? Raised to something to give you a radical 5, which is 2.236. Good luck. Right? This was a little tougher here. Did I express this correctly? And without a calculator, I'm not going to try to approximate here, guys. I'm going to leave this for right now like it is. I said, Professor, is this doable? It is. You said I've not seen enough here yet to finish it up with what I want to see. But it is doable. Okay, with all that said, Mr. Park, I need for you to help me. My students need just a little calculus before we leave tonight. And what I want to close down class with tonight is this. I had a beautiful class tonight. And he's going to help me. Guys, I'm going to do this. Whew. I'm going to construct a table. Seems like I started out with tables at the beginning of class. So let's go to a table. And I want you to consider this. And he's going to help me. Now watch carefully, watch carefully. I said, Professor, here goes another table. I'm going to have an X column. Right here. Then I'm going to have something very strange for the Y column. One plus 1 over x raised to the x. We are college students, aren't we? This is not middle school, is it? We're not in middle school, are we? Oh, so let's try that. Now, I'm going to put in the X column selected numbers like this for a reason. I'm going to start with this. Here, 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 there. Maybe I'll jump down to this in this particular table. 1 million. Before I ask Mr. Park to help me, and he's going to help me, with that strange expression, 1 plus 1 over x raised to the x, with those x replacements, can anyone tell me what am I, as an instructor, if you look at those numbers in the x column, can anyone tell me, using a symbol, what am I representing in that x column? As you look at those numbers, 10, 100, 1,000, 10,000, I went down to 1 million. What might that represent that we've talked about in class? Give me a representation for the left-hand column.
2.
No, something else, easier. Just a representation. What is that x, or that left column, x column, what's that representing? Or how can I use something to represent it? What's it doing? Are those numbers getting large? And we think large as infinity. So am I having on the left here, am I trying to show that x is doing this? So I want x get large. Let's talk to me. What on earth the other column gets, I don't know. We're going to find out with his help. Now, Mr. Park, hang on. First, he's going to find for me, with the help of the calculator, what 1 plus 1 over 10 raised to the 10 is close to. Carried out to 4 decimal places.
It's 2.5937.
2.593.
7.
7. Now we're going to try 100 in that strange expression.
It's
Hang on. Why'd you get to 4 decimal places there?
2.7048.
Beautiful. Try 1,000. Raised to 1,000.
2.7169.
That's 165?
169.
9. Okay. Let's try 10,000. And tell me what on earth is that close to?
2.7181.
1.
Uh-huh.
I'm going to jump down to 1,000,000.
Okay.
Please tell me, in that strange expression, what on earth is that close to?
It's calculating.
What happened to the calculator?
Oh, it's 2.7183.
3?
Yeah, 2.7183.
Mr. Park. When I put 100,000 in, you got this,
Yeah.
right? And then I jumped to 1,000,000, you got that. Aren't these awfully close? Can you try 10 million for me?
Okay.
Put in 10 million. Is that program slow?
It's a lot of calculation because it's power of 10 million.
What'd you get?
The program cannot support.
Whoa. Okay. Now, guys, between these two, he made no mistake. It's worked out exactly the way it should work out. If the 10 million would work, and it would work, his calculator just wouldn't take it. 10 million, you'll get something close to 2.718 again. If I should ask him to put in 1 billion, if you could calculate that, you'll get, again, something close to 2.718. So guys, this side is getting close to, for an approximation, 2.718. Mr. Parks, is that true?
Mm-hmm.
Okay. Now, does anyone know, as we get close to closing down here, what on earth is 2.718? Students may do this. Middle school across the street, if I go across the street and say 3.14, they may say pi. That's the approximation for pi, 3.14. If I say square root 2, they may not know that one. Square root 2, 1 point something, is that true? They may not know that one. My students in pre-calc, I think some of my students may know what this was representing. Does anyone know what 2.718, just like 3.14 was representing pi? That's an approximation for pi. Does anyone know what 2.718 is an approximation for? E. They name this as E is approximately 2.718. They start using the letter E in mathematics. And I know when I first saw this, and I was one of those students where I asked questions. And the professor put an E there. I said, why E? Why didn't you call it C? Why didn't you call it F? Why didn't you use W? Why call it E? Then he got into this long story of why they recognize this 2.718 as E. And he tells us that this is representing a mathematician his name is Euler, spelled that way, and he did some work with this number, and his name started with an E. So I was always wondering, why do you use E? Another letter. And that was one story I've heard, why they used E. Euler's name. But E is roughly 2.718. Here goes. And me closing down here. To make connections, we've already discovered, we use f of x rather than y. We have already looked at this. True? That's an exponential. Restriction on that a was, I gotta remind you, I think a had to be what? Greater than 0. But do not let a be 1. That's where we started. X is what? Any real number. Now suppose I do this. Let's call it f of x again. Now since a is positive, is this a positive number? So why can't I use it for the base? So rather than put a there, or a raised to the x, can I not use this? Can I not use e as the base? It says as long as the base is greater than 0, and 2.718 is certainly greater than 0, right? And when I do that in mathematics, especially higher mathematics, this is an exponential, but they call this a natural exponential function that has a base e. Now, how does it behave? Slow down here shortly. Guys, what do you think a quick sketch of e raised to the x may look like? You know what 2 raised to the x? I did that one tonight. What do you think e, which is 2.718, what does it look like? Very similar. Does it have the same y-intercept? Is the same y-intercept, is it going to be 1? Replace x by 0? Was 2 raised to the x looking like this earlier? Something like that? Or an exponential? So might the e raised to the x take that similar shape? Not the same, but similar shape? And I'll let this represent then, for a quick reference, that's the sketch of e raised to the x. Okay, and e is roughly 2.718. Now, before I give you the little challenge problem, let me write this out. Guys, your textbook says e is equivalent to the limit, as x is approaching infinity, of this strange expression from that table. And Mr. Park says, yes, this side right here is getting close to 2.718. That's its limit. It's getting close to 2.718. It'll never get quite exactly to 2.718, so it can be something else, another digit afterwards. But it's getting close. So it's approaching E as this is happening. And that's the conclusion. By the way, is this what we're doing here? Was this side here approaching, what, infinity? These numbers?
Yes.
Out of that function is E. Make sense? Put the table there. Jeez. Now, we've done so much tonight. Let me see if I'm ready for it. I hope so. We have only a few minutes, so don't get all excited. Oh boy. Challenge problem. Don't get discouraged. Still a challenge. Is all this method left?
Just piles of my paper.
Oh, okay.
Somewhere.
And we didn't pass this out yet, did we?
We did it.
I'll have to pass it out
Uh-huh.
next class.
Oh,
I was
okay.
gonna hang on to it.
Should I?
Did you want to hang on to it for me?
Oh, sure.
I may lose it. Guys, don't get frustrated, this is a triple challenge. Okay, let's get a little discussion going. This is tough. I wouldn't expect anyone to get it. No, or at least calc classes here, I'm getting that. Is that function one-to-one?
Yes.
If it's not, I can't find an inverse. Do you think the way it's described, is it one-to-one? I think if I should scrap this, we just scrap it into a parabola. But, and since that parabola would not satisfy the horizontal line test, I just look at this side of it. And you just wipe out one side of the parabola, then that makes it one-to-one to pass the horizontal line test. So it does have an inverse. If I were a student, and my professor showed that to me, I'd say, well, professor, it's a one-to-one. So you said interchange the coordinates, no problem. That's a little partial credit, right? And then the second step, of the 2 steps, only 2 steps. Solve for y. That's the issue. Did anyone get y? Anyone solve for y? Oh, hold on. How on earth are you going to get y by itself? I know what I might try. I don't think it's going to work. You may say, wait, professor, can't you do this? Move the 3 over. Of course I can do that. That would leave, at least, the y terms to themselves. Is that true? And then I'm desperate. So why not try to maybe take out a common factor of y and have that? Nothing wrong. Do I have y completely by itself at this point? No. I got to get the y completely by itself. Stanford, here we come.
You can divide
Divide by what?
y minus 2.
Whoa, 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 look at this, Alexandra, I love this. She said, Professor, do this. Now, is the y completely by itself on one side yet?
No.
I got a y over here also. Don't I? I want y just on one side like we usually get, what, the x or the y just on one side, single. The other side has no x or y. But as a student, I probably would have done the same thing. Okay.
Complete the square.
Ooh. Of course, no one's going to receive credit for this. He says, Professor, I think, and I have not shown you guys, this is a challenge problem, don't worry about something like this, my goodness, this is a challenge. He says, Professor, I think what you have to do is you gotta complete the square. What, complete the square? We talked about that way back when we first met, didn't we? Are you telling me I have to go back up here, I'm not gonna do it tonight, and rewrite that with the help of completion of the square? And then maybe I can solve for y. He mentioned completion of the square. I haven't tried completion of the square yet. Bella?
Different question, that was the latest.
Okay, okay. So guys, I'll leave it at that. Think about it. This is not a quiz Wednesday, for goodness sakes. Okay, so I'll see you on Wednesday.